You can see the question on the screen, and question says that there is a relation on the set A. There is a relation on the set A. What is the given set A? I told you, in your relation, given set is very, very important. Given set is 1, 2, 3, 4, 5, 6. In your set A, there are 6 elements, 1, 2, 3, 4, 5, 6. And how the relation is defined on this given set A? How the relation is defined? Relation, in the relation ordered pair x comma y, such that y is divisible by x. Okay, this is how your relation is defined. If y is divisible by x, what is the meaning? Can we say x is a factor of y? Correct na? For example, if I say 2 comma 4 belongs to R. Why? Because 4 is divisible by 2, so obviously 2 is a factor of 4. So from here, can I write the roster form of this relation? Roster form of this relation. Roster form. In the roster form, we write the elements separated by commas. Okay, so roster form. Okay, if I start with first element 1, obviously 1 is a factor of 1. 1 is a factor of 1. 1 is a factor of 2. 1 is a factor of 3. 1 is factor of 4. 1 is factor of 5. 1 is factor of 6. So these elements will come. Now if I start with 2, 2 is factor of 1. 2 is factor of 2. Okay, 2 is factor of 4. 2 is factor of 6. If I start with 3, 3 is factor of 3. 3 is factor of 6. If I start with 4, 4 is factor of 4. If I start with 5, 5 is factor of 5. If I start with 6, 6 is factor of 6. So I got this relation. This is the roster form. Now here I can check for reflexivity, for symmetricity, and for transitivity. So how to check reflexivity? For the reflexive relation, every element should be self-related. Okay, from the given set A. And given set A, there are 6 elements, 1, 2, 3, 4, 5, 6. So for reflexive, we need to check 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6 should be there. Okay. So you can see 1, 1 here present, 2, 2 present, 3, 3 present, 4, 4 present, 5, 5, 6, 6. It means every element is self-related. So obviously from here, since 1, 1, 2, 2, 3, 3, dot dot up to 6, 6 belongs to R, it implies, or therefore R is reflexive. Okay, R is reflexive. First, now if I check symmetric, is it symmetric relation? For symmetricity, we check whenever AB belongs to R, it implies BA has to be in R. So check. See, 1, 2 belongs to R, but 2, 1 is not present. It implies obviously it is not symmetric. It is not symmetric. How to write? Since 1, 2 belongs to R, but 2, 1 does not belong to R, it implies R is not symmetric. Okay. What about transitivity? Obviously this relation is transitive. Why? Because x, y belongs to R. In the definition, x, y belongs to R if x is a factor of y. So if x is factor of y and y is factor of z, it implies x is factor of z. So obviously it is transitive.